All right, let's crank that difficulty knob up a little bit more, and let's tackle that next type of circuit. Again, this chart is going to be our saving grace here as we attempt to tackle this. Now, this one, it's super important how we classified it before. Like, the rules only really make sense if the classification makes sense. So here, how did we say we were going to classify this? Yeah, first we're going to tackle these two first, right? We're going to say B and C are wired in parallel to each other. So no matter what, we know that parallel means same voltage, different current, right? They're going to split the current. And then we got to talk about how they're related to A, though, right? So we're going to say the parallel combination is in series with resistor A. So the combination of B and C is in series with A. It's going to be very, very important. So here we've got 24 volts being supplied. You know me, I like voltage first. We got 18 volts here. And then here, there's really only two options that you could say for B and C. What are they? Yeah, all right. So the two main things that people typically say here is they say, all right, well, what would naturally make most sense, right, is we know that these things are in series, and we know that series means voltage needs to add up, right? So we see one main branch, so the voltage's got to add up to 24. So 24 minus 18 leaves us 6 volts. And then what people tend to do is say, all right, so 6 volts, 3 volts, 3 volts. Because 3 plus 3 plus 6, those are all in series, gives us 24. And that's not right, unfortunately. So here's how we're going to look at it. A is wired in series with the parallel combination of RB and RC. So what that means is A is really splitting the voltage with this combined component that we're calling BC. So that looks like this. VBAT equals VA plus VB plus VC. So we get 24 volts equals 18 plus this VBC thing. So it's this mystery component. And what that means is that there's 6 volts left over for BC. So what we're saying here is that this is like hooking up these two in parallel to a 6 volt battery. That's the way you got to think about it, right? We've got a 24 volt, but this thing in series is taking up 18. So then connected across these 2 points here is going to be 6 volts. And what this rule really means is that the voltage across those points is going to be the same for all branches in between those 2 points. So if I put my probes here and here, that's going to give me 6 volts. And everything in parallel to that section is then going to give me 6 volts. Right? So we say RB is wired in parallel with RC. So that means this is how many volts is being supplied to that, right? Because 18 is being taken up by A. So there's only 6 volts left over for the BC connection. So if that is 6, then each of those in parallel is going to get 6. Because again, you got to think about it as like 2 separate paths here, right? We can do one where we go up, in which case 18 plus 6 gives us 24 volts, goes across. Or we can go down. 18 plus 6 volts will also give us 24 volts. And the way this works is like, well, it's again really counterintuitive to how conservation of energy works, but it's not. Again, because we know parallel means that these things, they're going to get equal voltage, but their currents are going to add up. So what this means is that these two in series here are going to get, like, this thing here is going to get way less of the voltage, as we can see, right? 18 volts is going here, only 6 is going here. So these two bulbs would be really, really dim. And if we knock one out, well then they're going to share it a little bit more equally, depending on what their resistances are. But this is going to be way less because they're in parallel with each other. And that's how the voltage is going to work. And that's the trickiest part, is resisting the urge to say, oh, series, so 18, 3, 3, that gives me 24. No. This is what we want to focus on, right? A is not in parallel with B, A is not in series with B, not in series with C. It's in series with that combination. And that's how they're going to share the voltage. So let's take a look at how current works now. So we can start with A. I think that missing current's a little bit easy, right? So it goes back to our main just series connection, right? Series means current is equal. So we can say A is wired in series with the parallel combination of B and C. So what we can say is that I bat equals IA equals IBC. That's right. Those are the three things in series. This is in series with this, in the main branch with the battery. So I bat equals IA equals IBC equals 1.24 amps. So there is 1.24 amps of current flowing through resistor A. But we know how parallel works, right? We know 1.24 comes around this way, and then it gets here to these two parallel branches. So it's going to split off. Some of it's going to go up, some of it's going to go down. But when they get back here, those two branches are going to combine back together to go through resistor A there with the 1.24 volts again. So what we're going to say is B is wired with parallel with C. So if we know that the current going to the BC connection there is 1.24 amps, and we know that 0.38 is going down into resistor C, well, the rest has got to be going to B, right? 'Cause that's how this works. The current being supplied to that set of branches is going to add up. And right now, the current being supplied to that set of branches is 1.24 amps, and those will add up. So we can just subtract out to find that the current through B is going to be about 0.86 amps. Now that's a little bit tricky, so we're going to try another one. We're going to walk through that one. Okay, so we're going to go to schematic 6 here. And this one's a little bit easier because we took the tricky part out. Or did we? All right, so we've got 3.5 volts, 3.5 volts, 5.5 volts. So you know me, I like doing voltages first. So again, A is wired in series with the combination of B and C. Right? So again, we're not going to say 5 VA plus VB plus VC because that's going back to schematic 1 type stuff. Right? The VA plus VB plus VC, that's this one right here. A plus B plus C. So we're on schematic 6. So it's a little bit trickier. Try it out. Okay, so let's take a look at it and see how you did. VBAT equals VA plus VBC. Those are the things in series, right? It's really two things in series. This in series with this combination. So this voltage plus this voltage. Parallels are just straight up equal, so 3.5 plus 5.5 gets us 9 volts to there, and that should say battery, not. Yeah, ugh, I'm so close to being perfect. VBAT equals 9 volts there. So 5.5 here, 3.5 to this parallel combination, that adds up to 9 volts. Now how about the current? Try that one out. Alright, well let's take a look. RB is wired in parallel with RC, so we know that though it's in parallel, how does current work? Right here in parallel, current just adds up. So we can see here that, whoop, that's next. So we can see here that IBC, so the current coming into that parallel combination and out of that parallel combination, is equal to IB plus IC. So in this case, that's going to be 0.66 plus 0.33. So the current flowing in and out of this parallel combination that's being split up into these two parts is 0.99 amps. So we got 0.66 up, 0.33 down. When they come back together here, it's going to be 0.99. And that gives us a little bit something, right? Because now we know A is wired in series with the parallel combination. Right? We know how current works in series, right? Current's just straight up equal. So if we know that the BC is 0.99 combined together, that means it's 0.99 everywhere in this branch. 0.99, 0.99, 0.99. So what this means is 0.99 amps of current comes out of the battery, comes around this corner, splits up. Some of it goes up, some of it goes down. But when it comes back together, it's back to being a full 0.99 amps of current again that goes back into that side of the battery. How'd you do? Good? Maybe? Hopefully? All right. Well, I'm not going to walk you through this one because this is your encompassing assignment for the week. But you already kind of saw it there. Spoiler alert. I want you to do this one. I want you to try this one out. All right, so we'll make this a little bit smaller so we can kind of see this a little bit better. Go a little bit smaller. All right, so that's for B there. So resistor B is right here. And resistor A is up here. So this is resistor A. This is resistor B. This is resistor C. This is resistor D. This is resistor E. Now, you can do like I did, try and tackle voltages first and then tackle currents, but there are definitely going to be some voltages that you have to solve for before others, and some currents you have to solve for before others. You got a little bit of a freedom, but I would say start small and work your way out. Start small and work your way out. Let me know if you have any questions about this. You probably should, because this is way harder than anything we've done. It's kind of like combining the last two types of schematics we just saw into one mega schematic. But definitely check your answers with me, and your encompassing assignment is going to be to make and explain everything that shows me how to do this. So you walk me through this step by step with the work, kind of like here, explaining it all out. And that's all you got to do this week. So once you solve it out, check in with me, show me your work, make sure it's all set, and then you just got to talk through it. And that's all you got to do. So hopefully this isn't too intimidating. I mean, I probably shouldn't have made it a red color, and that's probably not helping anything else. But try it out and let me know how it comes out.